Interaction with React. How do you make programs that respond to user input and are dynamic? Let's find out. We'll discuss mouse events, unidirectional data flow, the notion of state, and React's useState hook. What I'm thinking of making here is just a program that draws a circle, and that circle follows your mouse around as you move your mouse. For this to happen, we need two key ingredients. One is we need to know where your mouse is at any given point in time. And the second key ingredient is state. We need to keep track of where your mouse is such that we can move a circle around in response to that action. Let's start making this in code. I'm going to start by forking this Let's Make a Face Part 2 because that has the React stuff already set up. Then I'll go into the code here and just start by changing the title to mouse follower. And then I'll just, to set my intention, I'm going to update the description to be a program that follows your mouse with a circle. And then over in index.js, I'm just going to remove everything that we don't need. Except for, maybe I'll leave one circle because we're going to need a circle. All right, now we're ready to rock and roll. It's broken right now because CX, CY, and R use variables that we don't have. So let's make some new variables to use here. Const circle x equals width over 2 and const circle y equals height over 2. I'm just going to set them to be in the middle as a starting point. We're eventually going to want these to change as you move the mouse, but this is just a placeholder value. And then we can take circle x and set it to be cx, and we can take circle y to set it to be cy. And then r, let's just call it circle radius. And then we can define const circle radius equals, let's say 30. We can change it later. Okay, so we have a little dot there. All right, phase 1, so to speak, is complete. We have our starting point. The next thing I want to do is add an event listener so that we can get the position of the mouse as you move it around. The question now is, on which element do we listen for the mouse movements? We could put it a couple different places. We could put it on the window, we could put it on the body element, but since we have this SVG, let me try adding it to this SVG here. On mouse move equals handle mouse move. And we don't have handle mouse move defined, so let me define that to be a function. And in this function, let's just say console.log mouse moved. Now if we open up the console and I move my mouse, see it outputs. It says mouse moved a bunch of times. All right, so far so good. Now we need to know where has the mouse moved to. We can make it accept as an argument the event. So let's take that event and just log it to the console and see what we see. When I move my mouse, we get this event object. And what's in here? There are a bunch of properties on this event object. Some of these tell us where the mouse is at the moment. I think client X and client Y is our best bet. So let's try that. Console.log event.clientX and then console.log event.clientY. Now when I move the mouse, we get these different coordinates, which pretty much looks correct. I would like to extract client X and client Y as local variables. So we can say const and use ES6 destructuring to say client X and client Y equals event. And then we can construct an object and pass that into console.log. And by the way, this is another ES6 shorthand, which is equivalent to the following. Client X is client X, client Y is client Y. This is the property name on the object, and this is the value. And there's a new ES6 language feature that lets you just do it like this if the property and the variable have the same name. So now when I move the mouse it prints out a more clear message. Client X is this and client Y is that. So let's just test this a little bit. If we go to the upper left corner, they're close to 0, both of them. If we move to the right, client X increases and client Y stays low. But if we go down, then client Y increases and client X stays small. All right, we've got our first key ingredient. We know where the mouse is. Now we need that second ingredient, namely state. Unidirectional data flow is sort of a way of thinking about interactive systems that was popularized by React. It all starts when something is rendered on the page. After something is rendered or displayed on a page, a person becomes aware of it. When the person sees what's on the screen, perception and cognition start to come into play. Perception meaning visual perception, and cognition meaning you take what you see and you interpret it. What does this mean? After you think about it for a while, then volition and action start to come into play. You want to do something. You want something about this to change. After you decide to take action, then you can have some interaction with the system, be it a click of the mouse, a press of the keyboard, or the clicking of a button. Whatever sort of interaction it is, typically it triggers an event listener. When an interaction occurs, an event is dispatched, and all the event listeners that are registered with that particular event get notified that, oh, something happened. Usually, there's an event object that can tell you details about what exactly happened. For example, the position of the mouse or what key was pressed. The thing that completes the cycle of unidirectional data flow is that after some interaction happens and an event is fired, then the program will change state and re-render. In React, re-rendering takes advantage of React Virtual DOM reconciliation. This is what makes React reasonably fast, and it makes it so that you can write JSX that declaratively says, okay, this is what the DOM should look like, and React takes that virtual DOM and compares it to the actual DOM and only makes the actual changes that are required. They call it DOM diffing also. After rendering happens, the cycle begins again. Perception and cognition come into play. You see the updated thing, you decide to take some other action, another interaction happens, another event listener is triggered, state is changed once again, and then the cycle continues. This is what's meant by unidirectional data flow. The data flows in just one direction. Unidirectional data flow is the pattern or paradigm that we use to make interactive programs using React. Let's apply this pattern to our situation with this mouse follower. We've got our interaction and our event listener. What we need to do next to complete the cycle is set some state and then re-render based on that state change, namely putting the circle where the mouse is. This is where we left off in code. We know where the mouse is. Let's take a closer look at our code. We've got this event listener, handle mouse move. This gives us access to client X and client Y, the location of the mouse. We've also got circle X and circle Y, and we want it so that these coordinates end up as the coordinates of the center of the circle. How can we do this? We can introduce state, but what should our state be? I mean, what's going to be in the state? Well, since we want the circle to follow the mouse, the state, I think, needs to be the mouse position. And the mouse position has both X and Y. So we can use an object that has properties, let's say X and Y, to represent the mouse position. In React, the way of dealing with state is to use the useState hook. So let's do that. The first thing we need to do is import the useState hook from React like this. useState. By the way, this syntax for importing it says, all right, import the default export from React and call it React uppercase like this. But also import the following named exports, namely useState. Now that we've got useState available, we can use it. Before that, though, we need to change around this function so that it has a body in curly braces so we can add multiple expressions inside of here. So we've got begin curly brace, and then I'll add the ending curly brace down here. Then I'll indent all this. And now that we have those curly braces, we need to also explicitly return from here. This does the same thing as it did before, but now we can add more expressions to this function body. All right, so here's how you can use useState. I'm going to introduce some state called mouse position. Const mouse position, comma, set mouse position equals useState initial mouse position. When we invoke useState, it returns an array of 2 elements. This syntax here is the ES6 destructuring syntax for arrays. What it will do is take the first element of the array and assign it to the variable mouse position, and it will take the second element of the array and assign it to the variable set mouse position. Set mouse position is a function that we can use to change the state. The argument that we pass in to useState is the initial value of the state. The first time this component is rendered, the value of mouse position is going to be initial mouse position. We haven't defined initial mouse position, so let's define that. But what should that be anyway? I mean, what is that? That's going to be where the circle shows up before you move the mouse. So I think a reasonable place to put it is right in the middle of the screen. We already have some placeholder values, circle X and circle Y. I think what I'll do is I'll define initial mouse position to be an object that has 2 properties, X and Y. X can be width divided by 2, and Y can be height divided by 2. Now, since we're passing initial mouse position into useState, it's going to be available to us as mouse position. So we can access the value of X by saying mouse position.x and the value of Y by saying mouse position.y. Therefore, we don't need these anymore. These were just placeholders anyway. So I'm going to delete those 2 variables. And then we can use mouse position down here. So instead of circle X, we can say mouse position.x, and instead of circle Y, we can say mouse position.y. Let's see if this works. What we expect is that the circle should still be in the middle, and sure enough, there it is. The next step here is to somehow connect handle mouse move to set mouse position. And to do that, we need to have this defined inside of this function body here. So I'm going to cut that code from there and paste it inside of this function body like that. Now, instead of console.logging this, we can just invoke set mouse position with this object. But remember, our mouse position state shape is an object that contains X and Y, not client X and client Y. So we can just craft that object right here by saying X will be client X and Y will be client Y. All right, let's see if this works. If I move the mouse, the circle follows behind. All right, we've done it. We've closed the loop. Let me just review what's going on here in the code. When this code runs, the first thing that happens is that we define the initial mouse position to be an object with properties X and Y that put it in the center of our display. The first time our app component is rendered and this function gets executed, we pass in initial mouse position to useState. This initializes our state value to be this object, and we can use that as mouse position. Then we take mouse position and we use it to define CX and CY on our circle. So on the first render, our circle is positioned in the middle of the screen because mouse position is initial mouse position. Also the first render, the mouse move event listener is registered with our callback function called handle mouse move. When we move our mouse on this SVG element, this function is invoked and it's passed in this event object. And by the way, we don't actually need these parentheses, so I'm going to leave them out. This event object has event.clientX and event.clientY, which we are extracting here using ES6 destructuring syntax. Then we are crafting a new state object that has X defined as client X and Y defined as client Y. And then we're passing this object into setMousePosition. This is a function provided to us by useState. And when we invoke setMousePosition, that's what actually changes the state. When our state changes, this component is automatically re-rendered again. So this code runs again, and this time the value that we get for mouse position is the object that we passed in here. So now when we access mousePosition.x and mousePosition.y, what we're actually getting is client X and client Y from our mouse event that we got from moving the mouse. Every time you move your mouse a little bit, this function is invoked again. And so every time the mouse moves a little bit, we are calling setMousePosition with a new position and setting the state is updating, our app is re-rendering, and ultimately we see the circle move with the mouse. While this does work, it's not quite optimal. Let me tell you why. Every time this component renders, this function is being set to a new function, a newly defined closure. That makes it so that each time it renders, the mouse move event listener is actually unregistering the old version of handle mouse move and registering the new version again and again and again. This is a place where the performance here can be optimized. We can eliminate some of that extra work that React is doing. The way that we can do this is use another hook from React called useCallback. We can import it like this, and here's how we can use it. We can wrap this definition inside of useCallback like this. The first argument to useCallback is this function, and the second argument to useCallback is an array of dependencies, meaning it's an array of things that this function needs in order to run, or precisely it needs the most up-to-date version of it in order to run. The only thing that it really needs is setMousePosition. And luckily for us, setMousePosition doesn't change between renders because useState is just implemented that way. Now, with this in effect, our handle mouse move, it's not reset each render to be a new function, so it's only added once as the event listener, which makes the whole thing more efficient. Let's see if this still works. All right, sure enough it does. All right, that's how you can make a mouse follower, a basic interactive system using React. That's all for interaction with React.